Oh.
Earpods.
ఓకే జాన్సీ అవి తీసి నాన్న పిక్చర్ వేసుకుంటుంది.
Okay. So, good afternoon, students. Today we are going to discuss about the polynomial by using Cayley-Hamilton theorem. Okay. So here we have a question that is if A equal to 1, 2, minus 1, 3. So this is 2 by 2 matrix. 1, 2, minus 1, 3. 1 minute. So now we'll discuss about Cayley-Hamilton theorem second method. So that is if A equal to 1, 2, minus 1, 3, express. So A power 6 minus 4 A power 5 plus 8 A power 4 minus 12 A cube plus 14 A square. Okay, so we have to express this question in the polynomial of A. Okay, so all of you take this question. Okay, have you taken this question? All of you write down the question. Okay, finished?
Yes, ma'am.
Yes, ma'am.
So now, so how to do this problem now? First of all, so what is the question? So the question is here, if A equal to 1, 2, minus 1, 3. 1, 2, minus 1, 3, express. So we have to express this question in polynomial A.
A power 6 minus
Minus
4 A power 5
mm,
plus 8 A power 4
8 A power 4
minus 12 A cube
12 A cube
plus 14 A square, ma'am.
14 A square.
A square.
So what is the question? We have to do as a linear polynomial of A or polynomial of A. Okay. So for that, we have to use Cayley-Hamilton theorem. So what is the Cayley-Hamilton theorem statement? Here, the statement of Cayley-Hamilton theorem is every square matrix satisfies its own characteristic equation. So that is the statement of Cayley-Hamilton theorem. So what is the statement? Every square matrix satisfies its own characteristic equation. Okay, so that means here we need to calculate the characteristic equation. So how to find the characteristic equation for 2 by 2 matrix? For any matrix, we have the formula to find the characteristic equation. So the characteristic equation is, so therefore, the characteristic equation is, so what is the equation here? That is det of A minus lambda I equal to 0. So this is the characteristic equation formula. So how to find the characteristic equation? Here we have 2 by 2 matrix, no? And the diagonal elements are here 1, 3, isn't it? So the diagonal elements are 1, 3, 1 and 3. So for the diagonal elements, we need to add minus lambda. Okay, so that's why that will be 1 minus lambda, 2 minus 1, 3 minus lambda. That is equal to 0. Okay, so 1 minus lambda, 2 minus 1, 3 minus lambda equal to 0. But we have a shortcut method. So what is the shortcut method? Anyone? It is 2 by 2 matrix, no? How to
Lambda square minus
Lambda square minus
lambda plus det.
minus lambda into
trace A.
Of
Trace
it.
A
Trace A.
plus
plus det A,
det
ma'am.
A equal to 0. Okay, plus det A equal to 0. So lambda square minus lambda into trace A. So we have to do. Okay, so
Trace
we
is
have-
4, ma'am.
trace A is 4 because the diagonal elements are 1, 3. So what is trace A? Sum of the diagonal elements. So that's why this will be 1 plus 3 plus det. So 1, 2 minus 1, 3. Okay, so AD minus BC form. So lambda square minus lambda into
4
4
lambda.
plus this is
5, ma'am.
3 plus 2. Okay, so what is the equation? Lambda square minus
Minus 4
4
lambda plus
lambda
5
Plus 5.
plus 5 equal to,
is equal to 0, ma'am.
okay. So by here we have to use Cayley-Hamilton theorem. So what is the statement of Cayley-Hamilton theorem? Here we need to write the Cayley-Hamilton theorem statement. So by Cayley-Hamilton theorem, so which states that, okay, so what is the statement? Every square matrix satisfies its own characteristic equation. Okay, so what is the meaning of this? What is the meaning of this statement? Every square matrix satisfies its own characteristic equation means, so instead of lambda we have to put A, right? Isn't it?
Yes, ma'am.
Ma'am.
So this will be A square minus 4A plus 5 instead in place of
I, ma'am.
yes, constant we have to put I. Okay, so because these are all in these are all matrix, no, that's why we have to write the for the constant also we have to write in terms of matrices. So that's why we have to put I here. Okay, so no need to prove this one because in the question they have not mentioned verify Cayley-Hamilton theorem, isn't it? So directly we can take this equation in terms of A. Okay, so that is A square minus 4A plus 5I equal to 0. Okay, so now here I am writing this one in terms of A. So A square in terms of A means, so that is A square equal to, that is 4A minus 5I. isn't it?
Yes, ma'am.
Okay. Naveen, once call me, Amma. Naveen, are you there? Roll number 89.
Yes,
Ma'am.
ma'am.
సో క్లాస్ అయిపోయాక ఒకసారి కాల్ చేయండి.
Okay, ma'am.
ఓకే. సో a square equal to 4a minus 5y. Okay. So we have to write here a square. So a square we can write in terms of a. So that's why this will be a square equal to 4a minus 5y. A square equal to 4a minus 5y. So if I multiply a on both sides, so then this will be converted to, so a into a square is a cube, that is equal to
4a square.
4a square. If you multiply with a on both sides, no, you will get a square, sorry, a cube equal to 4a square minus 5 into I into a. So I into a is nothing but a. So then a square equal to 4a, sorry, a cube equal to 4a square minus 5a. So like that, here I am multiplying with a on both sides once again, because here the highest power is in terms of a power 6, right? So we need to find up to a power 6. Similarly, we can write that is a power 4. Okay, so multiply with a on both sides, then you will get a power 4 equal to 4a cube minus 5a square. Okay, so like that. Next one. So a power 5 equal to, again multiply with a on both sides. So then this will be 4a power 4 minus 5a cube, isn't it? Next one. And the last term is a power 6.
A power
Right?
6, ma'am.
So a power 6 equal to, so 4
4
a power
A power
5
5 minus 5 A
minus
power
5
4.
a power 4. Okay, so now we have to substitute all these values here, but here I am using one technique. So that is here we have to simplify this one. Okay, we have to simplify this one. So we have to simplify this one in terms of a, right? So that's why the given polynomial is, so this is our given polynomial. The given polynomial is a power 6 minus 4a power minus 4a power 5 plus 8a power 4 minus 12a cube minus 14a square. Okay. So what is the highest power here?
Power 6, ma'am.
A power 6. So now here I am substituting a power 6 value here. Okay. So that is a power 6 value is here a power 4a power 5 minus 5a power 4. Okay, so remaining polynomial you should write as it is. Okay, so that is 4 minus 4a power 5 plus 8a power 4 minus 12a cube plus 14a square. So simplify this one. So here we have 4a power 5 minus 5a power 4 minus 4a power 5 plus 8a power 4 minus 12a cube plus 14a square, isn't it? So this is a 4a power 5 minus 4a power 5. So here we have a minus 5a power 4 and this is 8a power 4. So from that we can write 3a power 4. And the remaining elements you can write as this. Okay, so that is minus 12. The remaining polynomial is minus 12a cube plus 14a square. Okay, so what is the highest power here? A power 4, isn't it? Okay, so now I am substituting a power 4 value. So what is a power 4? A power 4 is nothing but here 4a cube minus 5a square. So 3 into 4a cube minus 5a square into the remaining polynomial is this one. So that is minus 12a cube plus 14 a square, isn't it? Okay, now again we have to simplify that one. So 3 into
12a
4,
cube
12a cube minus
15a square
15a square.
minus
Remaining polynomial is this one. Okay, 12a cube plus 14a square. Okay, so after simplification, we'll get
a square
so 12a cube
Yes, yes, square.
minus a square.
Minus
a
a
square.
minus a
Okay,
square.
so what is the value of a square, Amma? A square is
4a minus 5i.
so minus of this is 4a
4a minus 5.
minus 5i. Okay, so after simplification, we'll get this is
4a plus
minus
5.
4a plus 5i. Okay, so therefore, so this is our required polynomial. Okay, this is our required polynomial. So this will be in terms of a, right? Okay, so this is
Yes,
also most important question. So all of you make a note of this problem. Shall I wipe off my screen?
No, ma'am.
Ma'am, I have a question.
Yes.
What if they asked us to just find out the value of that big polynomial, but they didn't say we have to find it out in the form of a?
Which you have to express this total term in terms of a.
Yeah, but like, what if we had another question in which they didn't say we have to express it, but just find the value of it?
That will be you have to find that one. This total term in terms of a means you can use any method directly. You can substitute all these values, a power 6 value, a power 5 value, a power 4 value. You can substitute directly here, and also you can find the a value like that. Otherwise, you can follow this method. No, this will be somewhat easy.
No, ma'am, what if they just ask the value for it? What is the value of it? Like,
The value is a, ma, in terms of a. In terms of a means, so what is the value of a? You know that a is this matrix, right? What is I?
what identity matrix?
Matrix of order 2, because the matrix will be in the form of order 2. No, okay.
Yes,
No
ma'am.
need to find the exact answer. Directly you can write in terms of the polynomial. The polynomial you need. So the polynomial is this one. Okay, this is the shortest polynomial. Linear polynomial. Linear means order should be 1.
So in the question bank, like, so we have to find it in terms of a, ma'am, not the actual answer.
Yeah, that is the question only. No.
Okay, ma'am.
Okay. That is the exact question. Sometimes they will ask like this: find the linear polynomial. Linear polynomial means so the order should be 1. So a power 1. Okay, so this one only. It should be a polynomial and the order should be 1. Okay.
Okay, ma'am.
Okay. So now let us take one more question. Shall I erase?
Yes, ma'am.
Yes, ma'am.
Okay. So all of you do this problem. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
So if A equal to, here also we have 2 by 2 matrix. Okay, here also we have 2 by 2 matrix. So that is A equal to 3, 1, minus 1, 2. 3, 1, minus 1, 2. Write 2a power 5 minus 3a power 4 plus a square minus 4i as a linear polynomial of A or linear polynomial in A. So what is the linear? Order should be 1. Okay, so same procedure you can follow. So by using Cayley-Hamilton theorem. Okay, so what is the Cayley-Hamilton theorem statement? Every square matrix satisfies its own characteristic equation. So how to find the characteristic equation? By using the formula that is det of A minus lambda I equal to 0. Okay. So all of you do that problem and tell me what is the answer. Do it fast. So all of you follow the same procedure. So now tell me the answer. Yes. So what is the characteristic equation, Amma? So what is the characteristic equation?
Lambda square minus 5 lambda plus 7.
So by using the characteristic equation, that is det of a minus lambda I equal to 0. So first of all, we need to write these two steps. 3 minus lambda, 1 minus 1, 2 minus lambda equal to 0. Tell me the characteristic equation, lambda square.
Minus 5 lambda plus 7.
7 equal to 0. Okay. So by okay. So by Cayley-Hamilton theorem, what is the statement? So here you need to write the statement. So that is every square matrix satisfies its own characteristic equation. So this is the statement for Cayley-Hamilton theorem. Okay. So now So what is our next step? So here we need to write we need to write the equation in terms of a. So that will be a square minus 5a plus 7i equal to 0. Okay, so a square minus 5a plus 7i equal to 0. So from this we can write a square equal to 5a minus 7i. Okay, so a square equal to 5a minus 7i. So if I multiply with a on both sides, no, we'll get, okay, so this will be a cube equal to 5a square minus 7a. Okay, so up to we need to find, yes, tell me. We need to find for a power 5.
A
So
power
this
5.
will be a power 4 equal to, again multiply with a on both sides. Then we will get that is 5a cube minus 7a square. Okay, so next a power 5 equal to, so this is 5a power 4 minus 7a cube, isn't it? Now we have to take the equation. So therefore, the equation is, sorry, the polynomial is 2a power 5 minus 3a power 4 plus a square minus 4i. Okay, so from this, so what is the highest power here? The highest power is a power 5. So that's why here we are writing. Okay, so a power 5 value. So that is 5a power 4 minus 7a cube. Okay, so that is after that we have to write the remaining polynomial. So the remaining polynomial is here minus 3a power 4 plus a square minus 4i. Okay. So now simplify this one. So 5 into 2, 10a power 4 minus 7 into 2,
14a cube, ma'am.
14a cube minus 3a power 4 plus a square minus 4i. Okay, so after simplification,
We get 7a power 4.
okay, so we get, so 10a power 4 minus 3a power 4 is 7a power 4 minus 14a cube,
Plus a
and the
square minus
remaining
4.
remaining polynomial is a square minus 4i. Okay, so now next, so what is our next step?
Substitute a power 4.
ఒకటే బాధపడతాను సెటిల్ చేసుకుని
Yes, all of you do that problem. Okay. Yes. So, what is the highest power here? Okay. So that is a power 4. A power 4 value is this one, that is a 5a cube minus 7a square. 5a cube minus 7a square. Okay. Minus 14a cube. The remaining polynomial is this one, right? So that is minus 14a cube plus a square minus 4i. Okay. After simplification, we'll get, so this is 45 a cube minus 49a square minus 14a cube.
I'm 35 a cube. ma'am.
35.
Sorry, 35 is the, so 3 5s are 30, 7 5s are 35, and this is a square minus 4i. Okay. Next. So alert gunnarannamata andaru.
21 a cube
So this is okay, 21a cube
minus 48 a square
minus 48a square
minus 4i.
minus 4i. Okay, so here highest power is a cube, right? So substitute a cube value here. So that is 21 into a cube means 5a square minus 7a minus remaining polynomial is 48a square minus 4i. Okay. Simplify this
105
one.
a square
Okay, so very good. Roll number 95, A2. Nishita, change your name as roll number. Okay. Okay. So this is, tell me,
105 a square
a square minus
105 A square
minus
minus
147 a
a
mm,
minus 45 a square
48,
48
48 A square minus
minus
4.
4i.
Okay, good. So this will be next.
57 a square
So after simplification, we'll get 57
yes,
57 a square
A square
minus 147a
147A
minus 4i.
minus 4i. Okay, so here we have to substitute a square value. So what is the value of a square? 5a minus 7.
5a minus 7i, ma'am.
So that is 57 into a square value is 5a minus 7i minus 147a minus 4i. Okay, simplify this one.
285a
285a
minus
399i
399i
minus 147a minus
147
4i.
minus 4.
What is the total answer?
138a
138a minus
138a
minus
minus
403i.
403i. So this is our required linear polynomial in terms of a. Okay. Shall I give one more question?
Yes,
So
ma'am.
this is our question bank question. So all of you open the question bank. Module 2. The question, 8th question. Part A, 8th question, Amma. See. Shall I erase this? Hello?
Yes, ma'am.
Okay. So all of you write down this question. Verify. First of all of you read the question carefully. So verify Cayley-Hamilton theorem. Verify Cayley-Hamilton theorem for A equal to 1, 4, 2, 3. Okay. And evaluate a power 5 minus 4a power 4 minus 7a cube plus 11a square minus a minus 10i. Okay, so a power 5 minus 4a power 4 minus 7a cube plus 11a square minus a minus 10i. So all of you do this problem. So what is our question? So first of all, we need to verify Cayley-Hamilton theorem, right? So how to verify Cayley-Hamilton theorem? What happens, students?
First, we need to find characteristic equation.
Yes. What is the characteristic equation? The characteristic equation formula is det of a minus lambda I equal to 0. So that is here the diagonal elements are 1, 3, right? So for the diagonal elements, we need to add minus lambda. So that is 1 minus lambda, 4, 2, 3 minus lambda equal to 0. So how to write the characteristic equation in shortcut form? So that is lambda cube minus
Square,
lambda
ma'am.
into 1 plus 3 plus det of 1, 4, 2, 3
Ma'am,
equal
lambda
to
square.
square, because this is 2 by 2 matrix, right? Next, what is the equation? Lambda square minus 4 lambda, so
Plus
this
5,
3
ma'am.
minus 3 minus 8 plus 5 equal to 0. Okay, so this is our characteristic equation. So according to Cayley-Hamilton theorem,
Ma'am,
what is
it's
this?
minus 5.
-5, ma'am.
So 3 minus 8, okay, minus 5.
-5.
Minus 5. Okay, so by Cayley-Hamilton theorem, every square matrix satisfies its own characteristic equation. Okay, very good. Roll number 95. Okay, so here we have to prove the Cayley-Hamilton theorem. So for that, instead of lambda, we need to write a. So that is a square minus 4a minus 5 into I, right? So here I am proving this one. Okay, so what is a square, Amma? All of you do with calculator and tell me what is a square, because here we have a question that is verify Cayley-Hamilton
9,
theorem.
A square is 9,
9, 16,
1 minute.
8 and 17.
1 minute. 1 minute. Okay, so this is 9,
9, 16,
16,
8, 17.
8, 17. Okay, so minus 4 into a given matrix. What is our given matrix? 1, 4, 2, 3. Minus 5 into I. I means
1001.
1001. Okay, so now verify Cayley-Hamilton theorem. So here I am randomly choosing one element. So first element. Okay, so 9 minus 4 minus 5. Okay, so that is 9 minus 9, 0. Is this equal to 0? Null matrix, right? So therefore, so from this we can write a square minus 4a minus 5i equal to 0. So Cayley-Hamilton theorem verified, right? Verified. Okay. Now, so what is our next step? We have to evaluate this one. Okay, so that means evaluation means we have to convert or we have to reduce this total polynomial in terms of a. Okay, so for that we have to take our characteristic equation by using Cayley-Hamilton theorem. The equation is a square. Okay, so a square minus 4a minus 5i equal to 0. So from that we can write a square equal to 4a plus 5i, isn't it? 4a plus 5i. So if I multiply with a on both sides, no, we'll get a cube equal to 4a square plus 5a. Okay, so again multiply with a on both sides, we'll get a power 4 equal to 4a cube plus 5a square. Okay. So now up to we need to find a power 5. Okay. So our next step is a power 5 equal to 4a power 4 plus 5a cube. Okay. So now substitute all these values in the given polynomial. So for that we need to take the given polynomial, that is a power 5 minus 4a power 4 minus 7a cube plus 11a square minus a minus 10i. Okay. So what is the highest power of the matrix here? So here a power 5 is the highest power and we have to substitute the value. So value of that one is here 4a power 4 plus 5a cube. Okay, so minus 4 into a power 4. The remaining polynomial is minus 4 into a power 4 minus 7a cube plus 11a square minus a minus 10i. Okay. Now simplify this one. Then tell me. After simplification, we'll get 4a power 4 minus 4a power 4 will get cancelled. And here we have 5a cube and minus 7a cube is there, right? So
Minus
that
2a cube.
minus 2a cube and the remaining polynomial is
Plus 11a.
minus a
Plus a minus
10.
10i.
Okay. Now we have to substitute a cube value. So this is our a cube value. So minus 2 into 4a square plus 5a, isn't it? And the remaining polynomial will be, so 11a square minus a minus 10i. Okay. So now simplify this one.
Minus 8a square.
After simplification, tell me. So
3a
minus a
square.
square is there and 11a square is there.
3a square
3a
minus
A
11a
square
minus 10a.
minus
11i.
11
Sorry, 11a.
11a
mm,
minus 10i.
10i. Okay. So now here we have to substitute a square value. So what is a square here?
4a plus 5a
4a
plus 5i.
5i minus the remaining polynomial would be, so that is a minus 11a minus 10i. Okay. So,
a plus 5i.
so a plus
5i.
5i. So this is our required linear polynomial. Okay. So one more question is there. I will tell you. Okay. So all of you write down the question. The question is verify Cayley-Hamilton theorem. So this is module 2, part A, first question. Shall I erase? Shall I erase my screen?
Yes, ma'am.
Okay. So now all of you write down this question and do this problem as a homework. Hamilton theorem. Verify Cayley-Hamilton theorem for 1, 2, 2, 2. Okay. And evaluate 2a power 4 minus 5a cube minus 7a minus 6i. Okay. So all of you do this problem and tell me what is the answer. So before that, roll number 66. Are you there? Roll number 66. 69. 76. 80. Roll number 80. 88. 99. A6. A6. Are you there? Present or absent? A9.
Ma'am, A6 present, ma'am.
A6 present. A9. B4. B6,
Yes, ma'am.
B6 present.
Yes, ma'am.
Just wait, I will check. B6, okay. B9 is also there. ఇప్పుడే వచ్చాడా ఏంటి?
లేదు మ్యామ్.
So A6, B6, B9. 3 members are present.
B6 present.
Okay, B6, B9, A6.
68.
68, okay, he's present. 66, 69, 76, 80, 88, 99, 9, B4. ఉన్నారా వీళ్ళు? లేరు కదా? Okay. So all of you did do this question, Cayley Hamilton theorem. So here all we have same type of question is there. So
Ma'am,
this
question
part here-
bank.
Yes,
Ma'am,
this is question bank question only.
Question bank part is second question. They asked us to find a power -3, ma'am. So do we multiply by a power -3 on both
On
sides?
both sides.
Okay, ma'am.
Okay.
I'll try it.
By using Cayley Hamilton theorem, we can find positive power, negative powers also. Okay.
Okay, ma'am.
Okay. So all of you and tell me the answer tomorrow. Okay, Amma. This session. Any doubt? So tomorrow we'll discuss about question bank. Okay.
Okay, ma'am.
Okay, Amma. Bye. So what is your last period entama?
BWD.
Okay.